in order to complete this video, you need to have your Chapter 2, Section 1 handout in front of you so that you can follow along and take notes as we go. So if you don't have it, stop this video and go to Canvas, and under the Chapter 2 module, you will find a copy of the handout if you need one so that you can print it. If you have your handout, let's go. Okay, so we start off with some definitions. The first one is inductive reasoning, and you all have a typo on your handout, so let's go ahead, cross out the word statement. We don't need that. Inductive reasoning is using a specific example or examples to make a conjecture. Okay. The next definition is for a conjecture. A conjecture is going to be a generalized statement that is arrived at by inductive reasoning. And then our next definition is for a counterexample, a statement or example demonstrating a conjecture is false. It only takes one counterexample to disprove a conjecture, okay? So that being out of the way, the next type of examples we're going to look at are shape pattern examples. So we take a look at this and we're being asked to draw the next shape in each picture pattern. So in this first set, you'll see I have one dot in the first picture. The second picture has 3 dots. And the third picture, if you count it, has 6 dots. So you take a look at this and you think to yourself, well, what change is occurring? What's happening? So I could say that 2 dots were added from picture 1 to the second picture. 3 dots were added from picture 2 to the third picture. And if I keep with that pattern, then the logical thing is that in the next picture, 4 dots will be added. And so with that in mind, we go ahead and figure that our last picture has 10 dots. And we go ahead and we draw that out. Not a very pretty picture, but it works. Another way to look at it is also we went from the top row of 1 dot, we added a second row with 2 dots, we added a third row with 3 dots, and so to continue we'd add a fourth row with 4 dots. Take a second and think about what would the next picture look like. That's right, we'd add a 5th row with 5 dots. Okay, continuing on to the second example, why don't you go ahead, stop the video, and see if you can figure out what the next picture in the pattern would look like. Okay, great. Did you really stop the video? You know you should, because the idea is for you to figure this stuff out pretty much on your own. Okay, you're really back now. So if you're really back now, we are going to go ahead and see that in the first picture we have 1 point. In the second picture there are 2 points. Third picture, 3 points on our circle, and fourth picture, 4 points. You'll also notice that in each picture as we add a point, we draw the segments connecting them, creating a triangle and then a quadrilateral, and so our next picture will be, as you probably already have drawn, 5 dots and a pentagon connecting them. Okay, so only connect the points. No diagonals. Okay, in this third example, again, take a look at it. Stop the, whoops, let me move that up so you can see it. Stop the camera. Take a second. What would the next picture look like? Okay, you're back. As you can see in the picture, the box is moving clockwise around the upper square. Upper left square, I should say. Slide that over. And so therefore, my next picture will have the 4 squares, and our little gray square will now move to this corner. All right, so that takes care of the first examples. We're moving on to the next page. Okay, we're on page 2 of our note packet, and we're looking at number pattern examples. And if you take a look, we are being asked to find the next 2 terms in each sequence. Okay, so when I look at this one, I'm like, all right, a 1, and then we go to a 10, and then we go to 100. And so I ask myself, is the same number being added? Excuse me, off the page. Is the same number being added? Subtracted? Multiplied? Divided? Okay. Is there a pattern in the addition? Is there odds? Are there evens? What's going on? Okay, so with that being said, if I take a look here, it appears, well, to get from 1 to 10, I could multiply by 10. To get from 10 to 100, I could multiply by 10. Oh, wait, it works again for 100 to 1,000. And so therefore, my next 2 would be, stop the video and fill it in for yourself. Okay, you're back. 10,000 and then 100,000. How many of you thought the pattern was each time I move up, I tack another 0 on? That would also be a legitimate description about the 2 terms that we found. Okay, and then it asks you to please write about how you found the 2 terms. You could say you multiplied by 10 to get the next term. You could say each term added another 0 to the number. That would be also a good explanation. Okay, moving on to B. Go ahead, take a look at it. See if you notice a pattern happening with it, and stop the video and take a guess at what you believe should be filled in. Okay, you're back. So when you look at this, there seems to be no logical reason, or by adding, subtracting, multiplying, to go from 1/2 to 9. There probably isn't. But if I look at the first term and the third term, there seems to be a connection between the 1/2 and the 2/3. Here we have a 1 and a 2, and then we go to a 2 and a 3. And if I skip and go to the 5th term, a 3 and a 4. I see a connection. Now if I look at the even terms, the 2nd, the 4th, and the 6th, I see a 9. We increased it to a 10. We increased it to an 11. With that, I'm going to go ahead, and you should too, fill in these next 2. They are 4/5 and 12. Okay, moving on to the next pattern. If we take a look here, well, I wanted to go from 0 to 3 and then 3 to 8. Again, stop the video, see if you can figure out the pattern. All right, you're back. Let's go ahead. We can see that to go from 0 to 3, I added 3. To go from 3 to 8, I added 5, added 7, added 9. Those are all consecutive odd numbers. Each time I move up one step, I increase the size of the odd number that I'm adding. So, to go from 24 to the next term, we would add 11 to take us to 35. And then to go to the next term, we add 13 to take us to 48. All right, our last number example is to write a conjecture based upon the examples, the specific examples that I've given here. So, stop the video, see if you can come up with a conjecture on your own. Okay, you're back. A conjecture, remember, is a generalized statement based upon the examples we see. So when I look at this, I see an odd number being multiplied by an even number, resulting in an answer that is even. And if I take a look at the next product, I see the same thing happening. The same, and again here. And so because of that, I'm going to make a generalized statement and say the product of an odd number, odd integer I should say, and an even integer will be even. Okay, we're going to stop our video just in the interest of time. Please go to the second video to finish the last examples.